Antacid contained introduction, characteristics of an ideal antacid, classification of antacid, some common use antacid, aluminum hydroxide gel, aluminum phosphate, basic aluminum carbonate, calcium carbonate, and references. So, first introduction, antacid. An antacid is a substance which neutralizes stomach acidity and it is used to relieve heartburn, indigestion, or an upset stomach. They come as a liquid or chewable tablets and can be bought from pharmacy and shops without a prescription. Characteristics of an ideal antacid. First, it should not be absorbed in systemic circulation. Second, it should not cause systemic alkalosis. Third, it should neither be a constipative nor laxative. Fourth, it should produce rapid and long lasting effect. Fifth, its reactions with gastric acid should not cause evolution of large quantities of CO2 gas. Sixth, it should be palatable and inexpensive. Seventh, it should inhibit pepsin. Classification of antacid. On First, on the basis of pharmacological action, first one is systemic or absorbable and second one is non-systemic or non-absorbable. So first we will see systemic antacid. These are soluble, readily absorbable and capable of producing systemic electrolyte disturbances. Example, sodium bicarbonate. Then second one is non-systemic or non-absorbable. They are not absorbed and act exclusively in the GIT, that is gastrointestinal tract. Example, calcium containing compound, that is calcium carbonate, aluminum containing compound, example aluminum hydroxide, magnesium containing compound, that is magnesium carbonate. On the basis of inorganic elements, they are further classified as aluminum containing antacid, example aluminum hydroxide gel, aluminum phosphate gel, etc. Calcium containing antacid, example calcium carbonate, tribasic calcium phosphate, magnesium containing antacid, example magnesium trisilicate, magnesium carbonate, milk of magnesia, then magnesium hydroxide and MgO. Fourth one is sodium containing antacid, sodium bicarbonate, combined antacid having example of aluminum hydroxide and magnesium hydroxide gel. Second example, aluminum hydroxide gel and magnesium trisilicate. Reactions of inorganic antacid. Antacid react with HCl in the stomach. Some common example reactions include calcium carbonate plus HCl gives calcium chloride plus water plus CO2. Then sodium carbonate plus HCl gives NaCl plus H2O plus CO2. Then aluminum hydroxide plus HCl gives aluminum chloride plus water. Magnesium hydroxide plus HCl gives magnesium chloride plus water. Then MgOs plus HCl gives magnesium chloride plus water. So these are all the antacid reactions with some common antacids. Some common use antacid. First one is aluminum hydroxide gel, Indian pharmacopoeia, molecular formula ALOH thrice, molecular weight 78. It is a hydrated suspension of aluminum oxide with variable amount of basic aluminum carbonate. It contains not less than 3.5% and not more than 4.4% weight by weight aluminum oxide. Preparation. It is prepared by addition of hot solution of potash alum to a hot solution of sodium carbonate. So here is a reaction, sodium carbonate plus potash alum plus water. This reaction gives sodium sulfate plus potassium sulfate plus CO2 plus aluminum hydroxide. Properties. Aluminium hydroxide gel is a white viscous suspension. It reacts with gastric acid to give AlCl, that is aluminium chloride, which causes nausea and vomiting. Here is a reaction. Aluminium hydroxide plus HCl gives aluminium chloride plus water. It is a very popular antacid and causes neutralization of gastric acid. Following mechanism. Uses. Used as a slow acting antacid to treat hyperacidity. Second, used for aluminium hydroxide, effective for use in the treatment of ulcer and hyperchlorhydria. Assay. An accurately weighed quantity of a gel, that is aluminium hydroxide gel, is dissolved in concentrated HCl by warming and dilutions with water to an aliquot of 10 ml. Means above solution we have to take, or we have to pipette out 10 ml a known excess of 0.05 molar disodium edetate is added, and a mixture is neutralized with 1 molar sodium hydroxide using methyl red as an indicator. This neutral mixture is warmed with on water bath for half an hour to ensure complexation of aluminium by sodium edetate. Hexamine is added and it is back titrated with 0.05 molar lead nitrate using xylenol orange as an indicator. Here is a factor for assay calculation. Each ml of 0.05 molar disodium edetate is equivalent to 0.002549 gram of aluminium oxides. Dose around 7.5 ml to 15 ml 4 to 6 times a day. This 7.5 ml to 15 ml amount is approximately 150 to 300 mg of aluminium hydroxide. Aluminium phosphate, molecular formula AlPO4, molecular weight 122. Official as a dried aluminium phosphate gel. NF is a national formulary, BP is British Pharmacopoeia. It consists mainly about 80% of hydrated aluminium phosphate. Preparation by interaction between aqueous aluminium chloride and sodium phosphate. Here is a reaction, aluminium chloride plus sodium phosphate. This reaction gives aluminium phosphate plus sodium chloride. Properties. It is a white powder or suspension having friable aggregates and contains not less than 80% aluminium phosphate. Practically insoluble in ethanol, water, alkali hydroxide solution, but soluble in dilute mineral acids. The gel has a pH 6 to 7.2. The acid neutralizing capacity is based on the release of trivalent phosphate ion due to the strongly basic nature. Uses. Used as a mild, slow acting antacid having a half the acid neutralizing capacity of aluminium hydroxide gel. Dose 5 to 15 ml 1 teaspoon to 1 tablespoon. Assay. Weight Weight quantity of sample is dissolved in 100 ml HCl and to 10 ml of an liquid. To this is added 25 ml 0.05 molar disodium edetate, made alkaline by ammonium solution and boiled for 10 minutes to ensure complexation. Ammonium acetate 1.55 gram and glacial acetic acid 6 ml are added and volume made 200 ml with water and pH adjusted to 4 to 5. Finally, dithezone 2 ml, that is the concentration of 0.025% weight by volume is added and the solution titrated against 0.05 molar zinc chloride until red perform along to get difference amounts mount sodium. Endpoint a black edetate consumed by the sample. Here is a factor, each ml of 0.05 molar Disodium EDTA is equivalent to 0.006098 gram of sample. Next example, basic aluminium carbonate. Molecular formula AlOHCO. Molecular weight 104.03. It occurs as a gel and works similar to aluminium hydroxide gel. The dietary phosphate is excreted as aluminium phosphate in the feces and made unavailable to form the phosphatic calculi. Preparation Preparation of basic aluminum carbonate involves reactions between stoichiometric amount of aluminum hydroxide gel, sodium bicarbonate in aqueous solution. Here is a reaction: aluminum hydroxide plus sodium bicarbonate gives basic aluminum carbonate plus NaOH. Assay: by complexometric titration similar to aluminum hydroxide gel under similar condition, adopting same procedure and reagents, each ml of 0.05 molar disodium EDTA is equivalent to 0.0039 gram of aluminum carbonate. Application: it is suggested for the management of phosphatic urinary calculi. Next example, calcium carbonate. Synonyms: precipitated chalk. Molecular formula CaCO3. Molecular weight 100.09. It contains not less than 98% and not more than 100.5% calcium carbonate. Calculated on dried basis. Preparation: prepared by mixing solution of calcium chloride and sodium carbonate, we will use calcium carbonate plus sodium chloride. Second example for preparation, it can also be prepared by passing CO2 through lime water. So we will get calcium carbonate. Properties: it is a white, odorless, tasteless, microcrystalline powder. It decomposes back to calcium oxide and CO when heated beyond 83 degrees Celsius. Its water solubility is enhanced in the presence of CO2. So here is a reaction. Then assay procedure: calcium carbonate is assayed by complexometric titration under alkaline medium. Sample is dissolved in aqueous HCl and the volume of resultant clear solution is adjusted to 250 ml. To a 50 ml of liquid is added 100 ml water and pH is adjusted to 12 to 15 with 1 normal NaOH. The solution is titrated against 0.05 molar EDTA using muriaxide naphthol green indicator to a deep blue endpoint. Here is a factor: 0 each ml of 0.05 molar EDTA is equivalent to 0.0051 gram of calcium carbonate. Uses: used as a fast-acting non-systemic antacid, used as a supplement for calcium deficiency, as a dentifrice due to mild abrasive property, and in cosmetic also it is used. References: textbook of pharmaceutical inorganic chemistry, guidance of teachers, and YouTube and Google. Thank you.